Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n plus 3 to the power of 3 plus n plus 5 to the whole power 3 is equals to 8, and we will solve this problem for the real values of n. So the very first thing we are going to do is, here first I can rewrite this equation as, here we have n plus 3 and I can write it as n plus 4 minus 1, because 4 minus 1 will be equals to 3. Similarly, here you have n plus 5 and we can write it as n plus 4 plus 1 and its whole cubed. Similarly, this is whole cubed is equals to 8. And after this step we can just simplify this term by substituting n plus 4 is equal to some variable, so that here I can take y is equals to n plus 4. So when you can put or take y is equals to n plus 4, then this equation will becomes in the form of y minus 1 cubed plus y plus 1 whole cubed is equals to 8. After that, here we need some important formulas, algebraic formulas, which I can write here. So that the very first formula is, you see that here we have y minus 1 cubed plus y plus 1 cubed, and I can apply the formula which is a cubed plus b cubed, it is equals to a plus b times of a square plus minus ab plus b square. So here I can apply this nice formula, and you can see here the value of a in this question is y minus 1 and the value of b is y plus 1. So now you can just put the values of a and b in this formula and you will get its output in this form, so that you can put the values of a and b in the right hand side and you get its output in the form of, here you have a square, so that you get here y minus 1. Here you have a plus b, so the value of a is y minus 1 and the value of b is y plus 1 times of, here you have a square and the value of a is y minus 1 whole square minus ab, and the value of a is y minus 1 and b is y plus 1 into b square, and the value of b is y plus 1 whole square, and it is equals to 8. So that now we can simplify the terms, and here first you can open these brackets and you will get here y minus 1 plus y plus 1, and here you can apply other nice formulas, so that I can write here, we need some formulas which is a minus b whole square and a plus b whole square and a square minus b square. So here we need these three formulas. So first I can write this formula here. So in this formula you get a squared plus b squared minus 2 times of ab, and in this formula it is equals to a squared plus b squared plus 2 times of ab, and this one is equals to a minus b times of a plus b. So here we need these three formulas, so which can we will apply it here one by one. So that the very first is y minus 1 whole square, it means we can use here this formula. So according to this formula we have y squared plus 1 squared minus 2 times of ab, and the value of a is 1, y and b is 1, so it will becomes minus 2y. And similarly here you have y minus 1 times y plus 1, so here you can apply this nice formula. So its right hand side is a minus b into a plus b, so it is equals to a square minus b square, so that we can apply here this formula and you get minus y square minus 1 square, and plus here you have y plus 1 whole square and y plus 1 whole square. We can apply this formula and you get its output in this form: y square plus 1 plus 2y, and it whole is equals to 8. And now in the next step we can just simplify the terms, and here you see that this plus 1 and minus 1 are gone, and here you get y plus y is equals to 2 times of y, so that here you get 2 times of y into, here you have y square, this is minus 2y and this is plus 2y, so this minus 2y and this plus 2y are gone, and here you get y square plus 1, and now you multiply this minus on both of the terms and you get minus y squared plus 1, and here you have whole is equals to 8. And now we will again simplify the terms, so that here you see that this minus y square and plus y square are cancelled out each other, and here you get 2 times of y into y square, plus here you have 1 plus 1 plus 1 is equals to 3, and whole is equals to 8. And now we can divide both sides by 2, so that here, or you can move this 2 in the right hand side and you get y times of y square plus 3 is equals to 8 over 2. And finally you will get, here you can multiply this y on both of the terms and you get y cubed plus 3y is equals to 4. Now we move this 4 in the left hand side and you get y cubed plus 3y minus 4 is equals to 0. And now we can solve this nice cubic equation, and now we can just break the middle term. So here you have the middle term is plus 3y, and we can break this plus 3y and we write this 3y as y cubed minus y plus 4y, and minus 4 is equals to 0, because here you have plus 3y and minus y plus 4y is equals to plus 3y. Now we will take common y from first two terms and you get y square minus 1, and here we take common plus 4 on the next two terms and you get y minus 1 is equals to 0. So now we can open this formula here, y square minus 1 square, it is equals to y minus 1 times of y plus 1, and here you have 4 times of y minus 1 is equals to 0. So now you see that we will take common y minus 1 and you get here, we can multiply this y on this term and you get y squared plus y, and here we take common this one and here you get 4 only, and whole is equals to 0. So here we have two cases. The first case is we take y minus 1 is equal to 0, and the other case is we take y square plus y plus 4 is equals to 0. So in this case you get y is equals to 1, and in the start of the question we will take here this y is equals to n plus 4, so that we will back substitute the value of y, and you get n plus 4 is equals to 1, and here you get the first root of this question is n is equals to 3. So n is equal to 3 be the first real root of this question, and in the start of the question I can tells us that we need only real roots of this question, so that now first I can check this quadratic equation has real roots or not by using the discriminant formula. So that here we have a is equals to 1, b is equals to 1, and c is equals to 4, and our discriminant formula is delta is equals to b square minus 4 times of AC, and we can put the values here. B square is 1 and 1 square is 1, minus 4 times of A is 1 and C is 4, so it is equals to 1 minus 16, and our delta is equals to minus 15, so it is less than 0. If our delta is less than 0, then we can say that this quadratic equation has no real root. So if it has no real roots, then we will reject it this case, because in this case we need only real roots. So finally we say that n is equal to 3 be the only one solution of this problem, and this is our final answer. So thank you so much for watching this video. Please subscribe to my channel for more exciting videos.